like if we take water and like put sugar in it,
Hmm.
it will be uh,
Hmm.
a
Homogeneous
homogeneous
mixture.
mixture. Like
Hmm.
if you if you take a
Hmm.
substance and
Hmm.
add other substance, there'll be no chemical
Hmm.
reaction. Like
Hmm. Hmm.
there'll be like it would be the same as the first
Hmm. Look,
as the
look.
first substance.
Okay, okay. थोड़ा थोड़ा आपने clear किया. Look here. The thing is now, in case of homogeneous mixture, what happens? Whatever is mixed in the homogeneous mixture, the particles are not visible. You cannot see it properly. Okay, for example, if you were to add sugar or salt in water, then after dissolving it, are we able to see the particles of sugar or salt in it? Yes.
What's it?
I'm seeing that whenever you have got homogeneous mixture, examples are like dissolving salt or sugar in water. So in that, are we able to see the particles of the sugar or salt? Can we see them?
No, no.
No. So that is the simple case about the homogeneous mixture, in which the particles of the substances present cannot be seen. Okay. So particles of substances cannot be seen. And then how would we define heterogeneous mixture? Just the opposite of homogeneous mixture, right now, in which the particles of substance can be seen very easily. Getting it now?
Yes.
Okay. So particles of substance can be seen very easily. Okay, before we move ahead, uh, Abu, do tell me, do you make notes of the class or not? Have you started making notes of the class?
Yes.
Okay. So far, how many chapter notes are complete?
Sir, I have just started the separation of substance.
Separation of substances. Okay, I would like you to send a few pages of your notes right now in the live class. Okay.
Okay.
Okay. You are attending your class from a smartphone or from your laptop?
Sir, laptop.
Laptop. Okay. I suppose if you have your own smartphone, or do you use your smartphone of your parents?
Sir, my parents.
Okay. So from your parents' smartphone, send the photos of the notes. Okay. Now.
Okay.
Okay.
Sir,
Huh.
but
Hmm.
like I have only wrote like
Hmm.
2 pages.
Okay, no issue, no problem. Send them only. Okay, now then we also talked about like why there was need of separation of mixtures, right? Because of various reasons we were separating the mixture. The one of the reason was to obtain the useful component, right? Or to
Yes.
remove the unuseful or harmful component from the mixture. Getting it now? Or in order to remove impurities to get a pure sample of the substance, a pure substance, right, Abu? Now, what
Yes.
were the methods of separation so far we have discussed? Huh? Physical methods which we have discussed so far. Can you please name some of them? Like winnowing, we have discussed hand picking.
Yeah.
There was few more. Please
Winnowing,
mention them.
handpicking, sieving.
Hmm.
Mm,
Winnowing,
the,
hand picking, sieving, magnetic separation. We talked about it as
yeah,
well now,
magnetic.
right now. Okay. Few of them, few of the discussion is still left. Like we have to talk about sedimentation today. आज हम sedimentation के बारे में बात करेंगे. Will you talk about how evaporation is used to separate two substances? What is decantation? What is filtration? What is distillation? What is churning? All of them we will be discussing today. Okay.
Okay.
I believe you have no problems in the previous methods. Threshing, that is clear now. Threshing क्या
Yeah.
होता है? Good. Okay, I believe we discussed few questions as well.
Yeah.
Okay, some of them were left because some concepts were left to be discussed. Now, talking about filtration, what is the process of filtration? Where do we do filtration? कहाँ पर हमें filtration करने की जरूरत पड़ती है? Yes, you see, in the process of filtration, it is the process through which smaller particles, like if there is dirt, they are separated from a solution. Yeah, by making the solution pass through a filter paper. If you were to look at this diagram here, yeah, I think have you guys done this activity in your school or not? In laboratory? No,
Done.
done now.
Yeah.
Okay, thereby you would have used a filter paper like this, make a cone out of filter paper.
Yeah.
Right now,
Yeah.
using this filter paper, you can filter out the dirt particles from the dirty water. Hmm. Okay,
Yeah.
and through this filter paper only liquid can pass. Liquid is able to pass through it. Okay, why? Because in this filter paper there are very tiny pores through which only a liquid medium can pass. Getting it now?
Yeah.
Okay, so we cannot use it to separate solid impurities from the mixture. Getting it? Okay, so as we pass liquid through it, here the liquid is being passed through it, and here there's a filter paper cone. Okay, so through the tiny pores, the bigger particles, that is the impurities or dirts, will be left back into this cone. Okay, getting it now? Okay,
Yeah.
now sometimes now you see filtration can be applied to separate pulp and seeds from the juice also. Huh? You know what is pulp
What's
and
that?
seed? Sometimes this method of filtration, we can use it to separate seeds also from the juice. Normally we use a strainer now, a tea strainer like a structure, or sieve. Okay, we normally use a sieve in order to separate seeds from juices. Okay, getting it now?
Yeah.
Hmm. Okay, so have a look at this diagram here. The process by which very fine insoluble solids can be separated from a liquid solid mixture. Now, always remember that the method of filtration works for those solutions in which there are liquid impurities. For example, if you were to separate a mixture in which the impurity is, let's say, oil, okay, and this is water, you can't separate oil from water using the method of filtration. Why? Because this method works for only liquid to solid solution. Getting it now?
Yeah.
Okay. So if there is solid impurities present in the liquid, then this method can be used, right? Okay.
Yeah.
Anything else?
No.
Yeah. Hmm. Okay. Look here. So, for example, um, if you were to have a dirty water, we just don't start by filtration. We have to go in a stepwise manner. So first thing what we will do, if you were to take a pond water or dirty water in which there are dirt as impurities, first you will allow it to rest. First you will allow it to rest. And that process has been called as sedimentation. Hmm? So sedimentation, Abu, listen carefully, it is defined as the process through which dirt and other heavier particles in mixtures settles at the bottom of the container or vessel here. Getting it now? So in this diagram, you can see the sand, that is the heavier particle present in the solution, after a few minutes have settled down at the bottom of this beaker here. Yes, Abu, is it getting clear or not? Simple thing here.
Yeah.
Simple here,
Yes.
right? Okay. Now, when the dust or the dirt particles have settled, now the clear water forms the upper layer, right? Upper layer हमारा clear water का है. Getting it now? So simply sedimentation means allowing the dirty water to rest for a while so that heavy and dirty particles can rest, can settle down at the bottom of the beaker. Getting it? Okay, then the clear water which is forming here, the upper layer is now moved to a different container, right? So here comes the next step. This is step number 1. This is step number 2. That is called as decantation. Now, what is decantation, Abu? It is nothing but as the technique through which.
Uh, the
Hmm,
water is gently poured
hmm,
into
hmm,
other beaker.
exactly.
Clear
So
water.
in this technique, what we have done, we have separated the clear water and taken it into a different container. Okay, so decantation is nothing but the process of gently pouring clear liquid into another beaker without disturbing the sediments. Okay, so that is how we define decantation. Okay, further, decantation has also been used to separate two immiscible liquids also. That we will come to in a moment, but let's again have a quick look at sedimentation. Read the definition, please. Read.
Sedimentation.
Hmm,
When the heavier components in the mixture settles, when water is added to it, the process
hmm,
is called sedimentation.
hmm,
Uh, this method is used uh, in separating grains from dust and soil.
exactly. Getting it now. Okay. Now you see the insoluble component that settles down at the bottom of the liquid forms the sediment. For example, you have this beaker. Okay, earlier it was dirty, but after 5 minutes, what happened? All the dirt particle has settled at the base of the beaker, right? So the water that forms the upper layer here. What do we call that layer of water? Because that has been called as
Clear.
supernatant. Okay, now that we call as supernatant. Okay, getting it.
Yes.
Yes. So this clear water layer has been called as supernatant, while this is the sediment. Okay. Now, this technique can also be used to separate two liquids which do not mixes with each other. Yeah. Later on, we will study that how do we separate two liquids which do not mixes with each other. So sedimentation is clear now. It is simply allowing the mixture to rest for a while so that the heavier dirt particle in it settles down. That is simple.
Yes.
Okay, then let's come to the next method, that is decantation. Now, decantation here, you see, it is simply the process after the sedimentation, which involves removing the water into the different container. Yeah, but this water still consists of some impurities in it. It is not 100% clear. Okay.
Okay.
Also, here you are seeing that simply type of liquid, that is in case here a water is being taken into a different beaker. While decantation is not only used to um, take the clear water, take out the clear water into different beaker, but also it can be used to separate two immiscible liquids. Yeah. For example, take the case of the water and oil here. You have got the kerosene oil and water. So kerosene oil being lighter, being having a lesser density, it will float above the water. Yeah.
Yeah.
Oil floats above water, right? Okay.
Yeah.
So once we pour oil in water, oil will form the upper layer of water and can be easily separated by gently pouring the mixture in another container till the oil has been removed. So also, if you were to consider a setup like this, say the same beaker, rather than having solid impurities in it, it has got oil floating above it. Yeah, this is
Yeah.
oil floating above it. Okay. Now we know that oil will be floating above the water. This is your water here. So very carefully and in a very gentle manner, we can pour this oil into another container here now. Let's take another container and you can very gently pour the oil in it. So oil will be flowing into the next container here. And water will be left here. Getting it now? Yes, Abu?
Yes.
So far we saw that decantation can be not only used to separate solid liquid mixture, but also it can be used to separate an immiscible liquid from the another immiscible liquid. Getting it now? So in the first case, you see case number 1 where you had a solid impurity. हमारे पास था solid impurity is here. So where you see that sediment is left back into the beaker. Getting it now? Yes.
Yeah.
While in the second case, you see that you have got the liquid as impurity. The impurity here is in liquid state. So both of them is simply decantation, whether you perform it for solid sediment or whether you perform it for liquid impurity, that is oil in this case. Is that clear?
Yes.
Okay. All right then. So here you have got the same thing is being basically done here, but you have got another setup here. So this is a separating funnel in which water and kerosene oil has been put. So kerosene oil starts to float above the water, and you remove this stop clock. Okay, now you open this stop clock. So as soon as the water empties the kerosene funnel here, sorry, the separating funnel here, as soon as the water level comes down and all of the water comes out of this hole here, then what do? We then stop the stop clock here. Getting it now? Thereby, kerosene oil will be left in this separating funnel. Yeah.
Sir, more like you
Hmm.
rotate the
Hmm.
stop clock, the faster
Hmm,
it
hmm,
comes.
hmm. Yeah, exactly. The faster you rotate it, the faster water will start to come out. And then you will be, in the end, you will be left with oil only.
Yeah. So
All
we
the
have to
water has
like close
drained
it
out.
very
Hmm.
fast.
Exactly, exactly. We have to close it very fast. So that's why it's done very slowly. Okay, if you were to move the knob very fast, move this stop clock very fast, then what will happen? Oil might also come out. Okay, now. Hmm. So that was all about decantation, right? Getting it now?
Yeah.
Okay. Now, after decantation has been done, okay, then comes the process of evaporation. Evaporation, there's no need to define it. It's simple. It's the process of converting liquid into gas or vapor by increasing the temperature of the given liquid, right now. Hmm.
Yeah.
So where do we use the evaporation in daily life? What is the application of evaporation? Like the salt that we consume, hmm, that also comes from various sources. For example, seawater, by evaporating the seawater, it
Yeah.
is obtained
Like
from there. Hmm.
uh, if we want to separate
Hmm.
water, uh, water
Hmm.
and salt, then
Hmm.
we like
Hmm.
we take a Bunsen burner, we burn it, then
Hmm. Hmm.
we like we keep a ice plate, like we take a plate and put ice cubes on it, and then
Hmm.
we hold it, then we keep a other like beaker on the side, then with the like with the uh
Mhm.
like with the water in the uh like in the gas form, it will get caught on the ice, like the cold plate, and then
Mhm.
it will drop in the beaker.
Hmm. The condensation takes place there.
Yeah.
Where water changes back from water vapor to liquid state. Hmm. Good. So in the case of evaporation, you see it's simply the process of removing water or like moisture from a mixture. So here it's a mixture of salt and water. Salt plus water, that is the mixture here. So we are trying to evaporate the mixture so that only salt is left here, for example here, right? Okay now. Okay,
Yeah.
so that is how evaporation is done. Okay, it's a process of conversion of water into its vapor. That is simply the process of evaporation. Hmm. Now, the process of evaporation takes place continuously wherever water is present. Wherever water is present, evaporation will take place. So, if you were to leave like a glass full of water in your room, and if you look at the level of the water after a week, you will find out that the level of water has come down. Why? Because it has simply evaporated. Getting it now? Okay. Also, do tell me that what temperature do we require for water to start evaporating? Yes. Yes, Abu, I'm saying that.
What?
What is the minimum temperature required for water to start evaporating? Hmm. Yes. Yes, Abu, are you getting my question? I'm saying
Yeah.
that water, like it requires 100 degrees Celsius to start boiling. But boiling and evaporation, they are somewhat different phenomena, because boiling is a very fast phenomena where water changes into water vapor very rapidly. Yeah. But in the case of evaporation, you don't necessarily need to achieve the 100 degrees Celsius temperature in order to start the conversion of water into water vapor. Are you getting it now? What I'm trying to say?
Yeah.
Hmm? So the temperature of evaporation is lower than the temperature required for boiling. Getting it now? Okay, so my question is that what is the minimum temperature required for water to boil? Yeah,
100 degrees Celsius.
100 degree Celsius. No. What is the minimum temperature required for water to evaporate? To boil it, if you say it 100 degrees Celsius, then it is correct. But for water to evaporate, it could be anywhere between 0 to 100 degrees Celsius. Getting it now? So if the temperature is anywhere between 0 to 100 degrees Celsius, then the water will evaporate. Yes, Abu? Okay, I hope it is clear. Yes?
Yeah. Yeah.
Hmm. Okay, then. Now, evaporation is there, then there is condensation also. Now, what is condensation? It is the reverse of evaporation, where we see there is a conversion of water vapor back into water form due to contact with a cooler surface, that is simply termed as condensation. Yes. So what basically goes on in the process of condensation? Hmm? Moments ago you explained condensation, right?
Yeah.
Hmm. So have a look at this setup here. Yes. You see the water vapors are coming out from this. Water vapor is coming out from this. And on this plate, we have put some ice cubes. Okay. Now, water vapor, when they are rising, they are what? They are lighter. Their weight is lighter. Getting it now? As compared to the water vapors are not very heavy. They are lighter. They are lightweight. Getting it now? And they are having more energy. More energy is there in water vapor. Yeah. That's why steam is known to cause more damage. If, let's say, if someone gets burned, okay, if someone, he or she, someone gets burned his hand by hot water or by steam, which will damage his or her hand more? Steam or hot water? Steam is nothing but it's water vapor. Yes.
Steam.
Steam will be doing more damage, doing more burn, because steam has got more energy. Can you say why steam has got more energy? Why water vapor has more energy? because it's in gaseous state, and any component in gaseous state is having more energy because their particles are free to move. Yeah, the particles can move in any direction, they are free to move, so thereby they have got more energy. Yes, no? If
Yeah.
someone is like lazy and sitting down, then it means it is he's or she is having less energy. If someone is very active and running here and there, it means he's having more energy. So water in the gaseous state is having more energy, right? Also, if the same particles of water vapor, same molecules of water vapor, if I were to reduce the temperature, if I were to cool it down, then what happens? It converts into water. You know the principle now? In order to convert water into water vapor, that is from solid to liquid, we need to increase the temperature. Yeah, increase the temperature now. आइस को वाटर में कन्वर्ट करने के लिए, लिक्विड वाटर में कन्वर्ट करने के लिए हम टेम्परेचर इंक्रीज करते हैं ना. Yes, Abu. To convert ice into water, we are increasing the temperature right now. And then again to convert water into water vapor, we are increasing the temperature. So as we move from here to here, that there's increase in temperature. The temperature is increasing. While if you were to move back from water vapor to towards ice, then the temperature you will require to reduce the temperature. Getting it now?
Yeah.
So the temperature has to be reduced. So thereby, here it was water vapor. Now, as soon as it came in contact with the cold surface, then it converted back from water vapor to the water. That is simply the process of what? What do we term it as? It's the process of condensation. Yes.
Yeah.
Okay, then that is simply condensation. It is defined as the simple process of converting gas or vapor to its liquid form by decreasing the temperature or pressure exerted on it. Getting it now? Okay.
Yeah.
Can we tell you where have we like what is the application of steam? Steam water vapor. What is the application of water vapor? Like in the early times, steam engine were being used now.
Yeah.
Yeah, steam engines were being used. Okay, then. So there you had the application. Now, there's one more thing. Distillation. It's not given in the chapter, but let's still discuss this one as well. Okay. So Abu, read the paragraph, please. Yes, Abu.
Distillation is a technique to separate two or more than two liquids according to their boiling point.
Hmm.
Distillation is commonly used to separate uh, eth- ethanol, the alcohol in alcoholic drinks from water.
Hmm.
Difference in a boiling point is a property used in distillation.
Hmm. Hmm. Okay. Look here. Like whenever two substances are mixed into each other and their boiling temperature is different from each other. Hmm. Their boiling temperature is different from each other. Suppose ethanol. Ethanol is a type of alcohol. Okay. Ethanol and if water are mixed together, then their boiling temperature is different. Water boils at 100-degree temperature, while ethanol boils at a temperature lower than 100 degrees Celsius. Yeah. So thereby we can separate them by heating them at different temperatures. It is also this process is also used in the extraction of various products from the crude oil. You know what is crude oil? Yes, Abu?
Yeah.
different products like different products from the crude oil, like the petroleum, like the diesel, like kerosene oil, like the Vaseline, okay, or the paraffin wax. All of them are extracted from the crude oil by heating it. Okay, so as I'm giving you example of crude oil. Now from crude oil we obtain a number of variety of products. What are the products that we obtain from crude oil? We obtain what? You obtain petrol from it. You obtain kerosene from it. Kerosene oil is obtained. We obtain diesel from it also. Okay. So all of these components that we get from crude oil, how do we get them? We simply start to heat the crude oil. We are heating it. And all of these have got different boiling points. They boil at different points. Suppose this boils at X, this at Y, this at Z degree Celsius. Okay, Abu.
Yeah.
Right? So we put them in a chamber like this. Crude oil is put in a chamber like this, and thereby we have got a structure like this. Okay, so this consists of crude oil. We start to heat this. Okay, now suppose if the heat at which I am heating it, it is X degree Celsius. Okay, so the component in this crude oil whose boiling point will be X degree Celsius will start to evaporate and come out from this hole into this chamber now, and we can collect it from there. Getting it what I'm trying to say, Abu?
Yeah.
And then if the temperature is now raised to then Y degree Celsius, then the component having the boiling point of Y degree Celsius will then start evaporating, then come back to this chamber where it will be separated out. Getting it now?
Yeah.
Here we are separating two or more than two liquids according to their boiling points. They all have got different boiling points. Okay, apart from using in the separation of petrol, kerosene oil and diesel from crude oil, we also use it to separate the ethanol, the alcohol in alcoholic drinks from water. So there also the process of distillation is used. Hmm. So have a look at this diagram here. From this diagram, what do we understand? Look at this diagram here.
Should I
Yes, Abu?
say?
Yeah.
Uh, uh, there's a solution.
Hmm.
Like there is a solution. Like
Hmm.
suppose salt.
Hmm.
Salt water. Uh, like there is a solution, and then
Hmm.
like it is heated by a Bunsen burner. So then the like the water contained in it is
Hmm.
uh, uh, like water like the water in it is like the in the form of gas is like getting evaporated, then it is
Okay, first of all, no, Abu,
collected by
the
this
the example which you have taken, it's not correct, because this process of distillation, if you were to read the definition once more, it says that it's a technique to separate two or more than two liquids. The example you have taken, it consists of a solid thing in it. You have taken salt now. Yeah.
sir, I have said
Hmm.
two or more, right?
Yeah, it could be two or more than two liquids. Okay.
Yeah,
So
it's water.
you won't be taking solid impurities in it. Getting it what I'm trying to say? If you
Okay.
have like ethanol and water, both of them are liquid. Both of them are liquid here. Yeah. Or you had the example of crude oil. All the components in it were in liquid state. So distillation is only done for separating liquid components. Okay, now according to the diagram here, you see, you will get to understand that In the process of distillation, we do selective boiling. Okay, now it's not like we will start to boil this solution at 100 degrees Celsius straight or 1500 degrees Celsius. No, having in proper information about the solution, we will be boiling it at a selective temperature. Getting it now? So look
Yeah.
closely here. The solution is being done what? It is being boiled here now. Suppose right now it is being boiled at a temperature of X degrees Celsius. Okay. And also let's say it consists of two liquids in it, where liquid one, L1, that means liquid one has a temperature boiling point of X degrees Celsius, while the liquid two has a boiling point of Y degree Celsius, and Y degree Celsius is more than X degree Celsius here. So far, note these points that X degree Celsius is the boiling point of liquid number one, and liquid number two has a boiling point of Y degree Celsius, and Y degree Celsius is more than X degree Celsius. Okay, any confusions?
No.
Okay, then good. Now, as soon as we start this burner, we will heat it at a, we will provide the temperature X degree Celsius. Okay, so thereby liquid one present in this solution will start to evaporate now. This is L1, that is liquid one. Okay, getting it now. So it will start evaporating and then it will come into this Liebig's condenser. This apparatus has been called as Liebig's condenser. Okay, so why condenser? Because here we will be condensing the liquid, because here the vapors are coming out now. Vapors are coming out, but we need to get it in the form of liquid now. Getting it, Abu? So
Yeah.
in this condenser, we pour in cold water from one side, and when the water becomes hot, it is taken out from the another pipe. Okay, so it's a structure like this, having hole in it, and the two sides are filled with cold water. The surrounding of this hole is filled with cold water. Getting it now? So far, everything's clear. So as soon as
Sir, I
this,
don't understand.
I am saying that this is filled with cold water. Okay, not the hole. The surrounding of the hole, the whole body of the Liebig's condenser, it is being filled with cold water. There's a continuous supply of cold water inside this, into this Liebig's condenser. So that what happens when the water vapors of liquid number one gets into this, it will start to condense and convert into liquid state. Is it clear?
Yeah.
Okay. Okay. What did you understood so far? Do tell me.
Yeah.
आपने क्या समझा अभी तक?
That uh,
Hmm.
like oh, we would burn the solution
Hmm.
with the Bunsen burner,
Hmm.
and uh, and then like we would
Mhm.
and then it would change into vapor, and then
Hmm.
it would go from the Liebig's condenser, and then
Hmm.
like there would be cold water surrounding it.
Hmm. Hmm. It's like this pipe. Okay, it's like this glass structure in which there's a hole, and via this hole, the vapors are coming inside it. The vapors of the liquid come inside this hole, right? And we need to convert this vapor into liquid state. So we will be lowering down the temperature now. You know the principle of condensation. We simply lower down the temperature in order to convert vapor back into liquid state. That is obvious. So if we were to put cold water in the glass body, yeah, thereby
Yeah.
condensation will occur here. That's why the name also is Liebig's condenser. And in the this funnel here, in this beaker here, the distilled water is stored. Okay, now, or if there's any other liquid, we would say that liquid is stored here, right?
Yeah.
Okay. So now when we have completely taken out the liquid number one, then we can increase the temperature to y degrees Celsius. Yeah. Liquid number one has been completely taken out from here. Then we can increase to temperature y degrees Celsius, let's suppose. Then the second liquid will start to again come into this condenser, and then it can be stored again into a separate container. Getting it now? So it's not just about boiling. Condensation is also involved in the process of distillation. Yeah, Abu, please explain the whole process. If it is clear, please explain Karim Puri process ko.
I didn't
Yeah.
I didn't understand the last thing.
Yeah, I'm seeing that, like, as I took the example of liquid number one, whose boiling point is x degrees Celsius. Now, as soon as you started to heat the solution here, as soon as you raise the temperature to x degrees Celsius, so at that time only liquid one was evaporating here, no? Liquid
Yeah.
one's what vapor were coming out. So it went
Yeah.
here into this Liebig's condenser, and then we stored it. Yeah.
Yeah.
So now we have taken out the liquid number one. Then we know that the liquid number two has a temperature of, let's say, y degrees Celsius. We don't know the name of the solution and neither its exact boiling point. So I have said just liquid number two and y degrees Celsius. Now you will increase the temperature. As I said, the temperature of y degrees Celsius, liquid number two is more than the liquid number one. Yeah.
Yeah.
So you will increase the temperature. Now the second liquid will also be taken out in the same manner as we took out the first liquid. So we have boiled the liquids at selective temperature. That is what is done in the process of distillation. You will boil the liquid at different temperatures. हमने दो different temperatures पे boil किया. First temperature पे boil करने पर हमें हमारा पहला liquid मिल गया. Now we want to take out the second liquid also. So we boil it at a different temperature now. Getting it now?
Yeah.
Hmm.
Sir,
Or we
like
can, yeah. Mhm.
like if there is only two liquid, then
Hmm.
we can like
Just leave it as it is.
raise the x.
Hmm.
See, like if yeah, we can
Hmm.
just leave it like the x,
Hmm.
and then we can
Hmm.
just take it
Hmm. Hmm.
in the other
Hmm.
beaker. Then
Hmm.
the first like the first beaker,
Hmm.
and then you can just leave it.
Exactly. That's what we can do as well. If the case is that you're having like more than two liquids, in that case, you could be
Yeah.
doing a selective boiling.
Yeah.
So distillation is nothing but it refers to the selective boiling and then subsequent condensation of a component of the liquid mixture here. Okay, now. So that is simply the process of distillation. I hope it is clear. Also, like, is distillation in the distillation, was there any chemical reaction going on?
Uh,
क्या कोई chemical reaction हो रहा है?
yeah.
No, there's no chemical reaction now.
Hmm.
Only the state is changing now. What we have done here, it is like very important to note here that distillation is not a chemical reaction, but it can be considered as a physical separation process. It can be considered as a physical separation process. Hmm? So try to understand here that we have just taken the components out of this mixture. It is still a mixture. Okay, now. So we have just taken out the component out of this mixture here.
Yeah.
Okay. So we have not like done any chemical reaction here. Okay, hope it is clear. And usually यहाँ पर हम एक thermometer भी attach करते हैं. Thermometer is also attached here. Okay, to monitor the reading of the solution here. Getting it now? Okay. Now talking about evaporation moments, so we're talking about it. In the diagram, you can see that shallow pits called evaporation ponds are constructed and salt water is allowed to stand in these. Okay, and after some time the water is evaporated, leaving behind only salt crystals. So common salt is separated in this manner. Okay, and after that also it goes through several process of purification. Okay, getting it now? Okay, so I believe we have discussed the important points in the chapter. Then few other things are also left. Like normally we see that so many liquids, so many substances dissolves into water. But is there any limit to it? Can we dissolve any substance into water? Can water dissolve it all? Hmm? Yes, Subbu? Like if you were to add 2 tablespoons of sugar in 1 glass of water, it will dissolve. But if you were to add 10 tablespoons of sugar in water, will that get dissolved or not? Yes,
Yeah, it can.
it can. It
Yeah.
can, it can, but there are some conditions for it. Okay, like if you were to increase the temperature, you would see that um, uh, the miscibility into water increases. Hmm. But there's a limit to it also. After some time, no more water, no more sugar can be added in it. Yeah. So that is what we will be discussing now. Okay. By the way, solution, solvent, solute, water, they that is clear now. What is solute, by the way? Solute हम किसे कहते हैं? Yes, Abu. Yeah, Abu, are you in the class or not?
Sir,
Hmm. I'm saying that solute हम किसे कहते हैं? What do you understand by solute? Read the paragraph here. Read the 2 lines.
a solution is a homogeneous mixture composed of two or more substances.
Hmm.
In such a mixture, a solute is a substance dissolved in another substance known as solvent.
Hmm. Can you give one example of solute and one example of solvent? Give one example of solute and solvent.
Solvent is
Hmm.
like the water in lemonade,
Hmm.
and the solute is what is
Hmm.
sugar and lemon water.
Lemon. Hmm.
Yeah.
That is solid. Okay. Solid is basically the substance that is dissolved in another substance, basically the liquid medium that is the solvent. Okay. Now back to our discussion that can water dissolve any amount of a substance? Yes. So you see, even though we see that water can dissolve a number of substances and so many solutions in it, but it has a limit to how much it can dissolve. After a certain point, we see that it also dissolves, it also stops dissolving any more of that substance. Yeah. So then you see that the substance will start to collect at the bottom of the container. So in that case, what do we say? Like if you were to keep adding sugar into water,
So my charging one for my laptop.
okay, no issue. So I was basically saying no, that can we dissolve any amount of a substance in water? No. The answer is no. After a certain point, in our next class, we will continue this discussion. After a certain point, we see that water stops dissolving any more substance in it. So in that case, we see that the water has, or the solution has now become saturated. Okay. So
Yeah.
saturated solution is like the one that contains the maximum possible amount of a particular solute in it, right? So for example, like if you were
Yeah.
to continue adding the salt in the water, in the small quantity of water, just one glass of water you have taken, and you are keep adding salt into it, there will come a point that the salt will not get mixed with the water. Instead, it will be depositing at the bottom of the glass. So at this point, we say that the solution has become saturated. That is, it is now incapable of dissolving any more of the salt particles in it. Okay. So that we will discuss in next class, and we will be solving few questions also. Okay now. So we will try to finish the